Hello and welcome. There are many unsolved problems in mathematics, but among the most famous are 7 Millennium Prize problems. The Clay Mathematics Institute has designated these problems as particularly important, and solving any one of them could earn a mathematician a reward of $1 million. So here are these 7 problems explained in very non-technical language. Number 1, P versus NP problem. Now imagine you have a lock and you are trying to open this lock using a right key from a huge bunch of keys. Now finding the right key, which is the solution, can be very time consuming. So let's call that NP. But if someone gives you a key, you can very quickly check whether that key works or not. So we call that as P. So P versus NP problem asks whether every problem for which a solution can be quickly checked, which is P, can also be quickly solved, NP. Number 2 is Ryman Hypothesis. Imagine you are trying to find a pattern in how certain points are spread out along a number line. Here the points we are talking about are prime numbers, which are numbers greater than 1 that cannot divide by any other number except 1 and themselves. So the Ryman hypothesis suggests that there is a certain line, and if you know how to find it, you can predict where these special points representing prime numbers will show up. But no one has been able to prove if this line really exists or if the pattern really works for all prime numbers. Number 3, Navier-Stokes existence and smoothness. So Navier-Stokes equation describe how fluids like air or water move. The problem is to prove whether solutions to these equations always exist and whether they can develop singularities or rough spots, which is kind of like proving whether a river can flow smoothly forever or if it must always eventually create a waterfall or a whirlpool. Number 4 is Hodge conjecture. When mathematicians study shapes, especially complex ones in higher dimensions, they use equations and certain special type of building blocks, which are called cohomology classes. The Hodge conjecture is like saying that some of these blocks can be built using even simpler ones, which are called algebraic cycles. It's like trying to find out if every complex Lego structure can be built using a certain type of simple Lego block. Number 5 is Birch and Swinnerton-Dyer conjecture. So this problem involves a type of equation called elliptic curves. The question is about understanding the number of solutions these equations have. It is like asking, if you have a certain type of puzzle, can you predict how many solutions or answers the puzzle will have? Number 6 is Yang-Mills existence and mass gap. So imagine you have particles like protons or electrons and forces between them, something like electromagnetism. The Yang-Mills theory is a way to describe such particles and forces. But we don't know if this theory always works. Also, we observe that these force particles have mass, but the theory doesn't explain why. So this is the mass gap problem. Finally, number 7 is Pointcare conjecture. And actually this problem is now solved. So this one was about understanding the nature of 3-dimensional shapes. The question was whether every shape that is simply connected, which means there are no holes, is basically a 3-dimensional sphere. So this problem was solved by Grigory Perelman in 2003, but he also famously declined the $1 million prize money. So all these problems are very complex, and the explanations just now provided are very, very simplified, but they give a basic idea of what each problem is about. And solving the problem could lead to significant advancements in mathematics and other fields. Thanks for watching. See you soon.